In this second video we're looking more in depth at quadratic equations and their roots. So we have our general rule. If alpha and beta are the two roots of the quadratic equation ax squared plus bx plus c equals 0, then if we add the roots together, so if we find the sum of the roots, so alpha plus beta must equal negative b over a from the equation, so negative b over a, and the product of the roots, so alpha times beta or alpha beta, is equal to c over a, and c and a come from the coefficients in the equation. So for example, if we want to find the sum and the product of the roots of the following equations, so we'll start with 2x squared plus 7x plus 6 equals 0. From this we know that a is 2, b is 7 and c is 6. So the sum of the roots is just negative b over a, so it's negative 7 over 2, negative 7 over 2. The product of the roots is the same as c over a, so it'll be c over a, or 6 over 2, which is 3. And we do that for all of them. So for 5x squared minus x minus 1 equals 0, a is 5, b is minus 1 and c is minus 1. So the sum of the roots is negative b over a, so negative of negative 1, which is 1, over our a, which is 5. So the sum of the roots, whatever they are, will be 1/5. And the product of the roots is c over a, so negative 1 over 5, or negative a fifth, or negative 0.2. So from this we know that when we add the two roots together we will get 0.2 or a fifth, and when we multiply the two roots together we will get negative a fifth, or negative 0.2. For the last one we have to do a bit of simplifying and rearranging. So x multiplied by x plus 8 being equal to 4 minus 3x rearranges and simplifies into x squared plus 11x minus 4 equals 0. So a is 1, b is 11 and c is minus 4. So the sum of the roots again are negative b over a, so negative 11 over 1, so negative 11, and the product of roots is c over a, so negative 4 over 1, or negative 4. Using this connection, if we know the roots we can work backwards and find a quadratic equation for which these are the roots. It won't be a unique solution, I'll explain why in a minute, because there are an infinite number of quadratic equations with roots 5 and negative 3, but we can find one of them using this. So we know that the sum of the roots, if we add the two roots together, we get 2, and that must be equal to negative b over a, because the sum of the roots is negative b over a. So negative b over a must equal 2. Rearranging, we get b is equal to negative 2 times a. The product of the roots, if we multiply the two roots together, we get negative 15, and we know that is equal to c over a. So c over a is negative 15, or c is negative 15 lots of a. So this is where we have an infinite number of solutions, because we can pick any value for a, and we know that b is negative 2 times it, and c is negative 15 times by it. The easiest one to pick is if a is 1, b is negative 2, and c is negative 15. So quadratic equations with roots 5 and minus 3 could be x squared minus 2x minus 15 equals 0, just substituting in a, b and c. We can also find equations whose roots are related to the roots of the original equation. So we can sort of manipulate our roots and work algebraically with them. The way you do that is you work out the new roots and get them in terms of alpha plus beta and alpha beta, because those are the values that we know from the original equation. So the quadratic equation x squared minus 3x plus 1 equals 0 has roots alpha and beta. We don't know what they are, but we know they're alpha and beta, and we want to find the equations with roots, firstly 1 over alpha and 1 over beta, and then secondly 2 alpha minus 1 and 2 beta minus 1. What we can do from our original equation is work out what the sum of the roots and the product of the roots are. So if we have x squared minus 3x plus 1 equals 0, we know a is 1, b is negative 3, and c is 1. So the sum of the roots, or alpha plus beta, is equal to minus b over a. So minus 3 over 1, so 3. So that gives us the equation, or the relationship, that alpha plus beta is equal to 3. So wherever we have an alpha plus a beta, we can replace it with 3. If we do the product of the the product of the roots, alpha beta is equal to c over a, so 1 over 1, which is 1. So we know that alpha times beta equals 1. So now to solve the first one, if the roots are 1 over alpha and 1 over beta, we need to find the sum of the roots and the product of the roots, and that will hopefully give us our b, c and a for our new equation. So summing 1 over alpha plus 1 over beta, just adding fractions to make the denominators the same, and we get alpha plus beta over alpha beta. Well, from our original equation, we know that alpha plus beta is 3, and we know that alpha beta is 1. So we know that the sum of the roots here is 3. So for our new equation, negative b over a must equal 3, or b is negative 3 lots of a. The product of the roots, multiplying them together, we get 1 over alpha beta, and we know that alpha beta is 1. So the product of the roots is 1, so c over a is equal to 1, or c is equal to a. So if a is 1, b is negative 3, because it's negative 3 lots of a, and then c is 1 because c is equal to a. So our equation with roots 1 over alpha and 1 over beta is x squared minus 3x plus 1 equals 0. It works the same with 2 alpha minus 1 and 2 beta of minus 1. We sum the roots, so add them together. We get 2 alpha plus 2 beta minus 2, which if we factorise gives us 2 lots of alpha plus beta minus 2. But we know from the beginning that alpha plus beta is 3, so we can replace that alpha plus beta with the 3, and solving it we get 4. So we know the sum of the roots is 4, so that means that negative b over a is 4, or b is negative 4 lots of a. Product of the roots, so expanding double brackets, we get 4 alpha beta minus 2 alpha minus 2 beta plus 1. Remember, we're looking for alpha beta terms and alpha plus beta terms, so we've got the 4 alpha beta. These two here factorise into negative 2 lots of alpha plus beta plus 1. Then we can replace alpha beta with 1 and alpha plus beta with what it's equal to, which is 3. Solving that we get negative 1. So the product of the roots, which is c over a, is negative 1. So c is equal to negative a. So if we let a equals 1, b is going to be negative 4 lots of a, so negative 4, and c is negative a, so negative 1. And that gives us the equation x squared minus 4x minus 1 equals 0. So if x squared minus 3x plus 1 equals 0 has roots alpha beta, then x squared minus 3x plus 1 equals 0 has roots 1 over alpha and 1 over beta, and x squared minus 4x minus 1 equals 0 has roots 2 alpha minus 1 and 2 beta minus 1.